Hello, welcome to my fifth tutorial about Torino, which is a project I'm using to speak about running Python web applications in Azure, using GitHub for the continuous integration and continuous delivery part. In this tutorial, I'm going to speak about Bicep templates, which are a way provided by Microsoft to implement infrastructure as a code, meaning that they describe the services which are needed to run a certain system in Azure. I'm going to describe how to run their deployment from your local environment, which is useful when you are modifying them or creating new Bicep templates. And I'm going to explain how to run them from GitHub using GitHub Workflows, so through automation. Let's first take a look at the Bicep templates provided in the project. If you go under Torino infrastructure, you will find the main template file, a nested template which contains alert definition. Alerts are used to get, for example, email notifications when something goes wrong in the web application. And parameters files with examples of parameters that can be used, assuming that you want to create multiple environments of your system, which is common when you are working on web applications. For example, development environment to have real services running in Azure for the developers of the system, test environment, and the production environment. In this example, of course, more environments can be handled. In this case, the template file is quite simple because it creates services only for storage account, a web application which will contain both the API and serve also the SPA that we showed in the previous tutorials. An application inside service to collect telemetries for monitoring, and a PostgreSQL database to store information about virtual file system, for example. So let's take a look at the main file. It contains several parameters at the top. So environment, for example, will be used to, environment and project name will be used to concatenate the full name of the services. So when you run the deployment for the dev environment, you will get services like dev, project name, and storage account, for example, or dev, project name, web app. Then there are parameters which are required to define the pricing of the system, like for example, the capacity of the database, the database administrator login password, which is required by the RM templates deployment. So Bicep templates translates into Azure Resource Management templates deployment, and application user password, which I will show later, because the system is done in such a way that the web application is using a user with lower privileges to access the DB, while the pipelines can use the user with higher privileges to run database migrations, for example, to create new tables or delete tables, etc. So to run the deployment from your local environment, you will need the Azure CLI, if you want to follow this tutorial, with a Bicep extension installed. So if I open a terminal, I can see the version of my Azure CLI typing add-z -b, and I can see the version of the Bicep extension using Azure Bicep version. Having both things installed, I can run the deployment from a local environment. And since it's not so obvious the command to use, I will explain it having a reference. It's not obvious because it requires some parameters which are specific to the Bicep template. So in this case, I will first do log into my Azure account. I select my user. Now I can close this. Don't mind about this login succeeded. Now I will select make sure that the right subscription is selected. So Azure account set subscription. So now by default, when I run a command, for example, to create a resource group, it will be created in the subscription. And I will create a resource group with a name following a certain pattern, a certain naming convention. So in this case, I will declare an environmental variable resource group equal dev Torino demo rg. Then I will create a new resource group in my subscription using the command Azure group create name resource group, a variable I just declared, and for location I will use West Europe. And it succeeded already. So what I can do now is to run a template deployment, Bicep template deployment in the resource group with the right parameters. I created a file reference sh, which I will push to the repository because it contains the required parameters to run it. So you have Azure deployment group create with the name of the resource group. Parameters will have the environment parameters. It will include this. You see that we have application of audience and application of issuer. These are passed here because they are configured as application configuration. So application settings for the API. So the API will enforce JWT bearer authentication using these two parameters, which are provisioned in this example. They are provisioned using the Bicep deployment. And we need a database administrator login password and a database app user password. But the first one is used to create a PostgreSQL database, and the second one is used to configure the application settings, because the API will then make requests to the DB using this password. Meaning that these two are going to be created by you, right? When you run the deployment. To generate passwords, I have a script in Python to do it. So it's quite simple. You need to import string and secrets, and you can generate passwords of the desired length this way. So, of course, there are many ways to achieve the same. You could even make up your own password, but I like this approach. So we create two. Now, it is important when you create these two passwords that you will handle them carefully, because you shouldn't put them in the source code, of course, but you need to configure them. So, for example, later when I show how to run the deployments from GitHub, we will configure these as secrets in the GitHub project. But for now, let me do like this, because I want to show how to run deployment from your local environment. So we'll declare db pass, and let me just check db application pass. Using the other password that was generated just now. Okay, so now I have two environmental variables that can be used by this script, by this command. And need to declare also the environment, which will be dev. And the project name, which is going to be Torino in this case. Now, if I go to the right folder, here I have template Bicep. I can run this command to provision the services in the resource group I just created. This deployment, of course, can take several minutes because you're going to create new instances of the database for the first time. And by default, these deployments are incremental, meaning that in the future, if I run again a deployment on the same resource group, the services from Microsoft will check the difference between the current state and what is described in the template Bicep file. So it will take longer the first time, but the next time it is run, it will complete faster. And once this is completed, we will have the alerts configured. Alerts are configured using a nested template, which is something interesting. So in this case, we have a module, alerts module, with the name of the file. Depending on the application inside service and the project, I mean the project site, the website, with certain parameters which are the same for the main deployment. So project name and environment plus a dedicated parameter which is action group name. The action group name is the name of the action group used to generate these alerts, and it is defined here: resource alerts action group with global location and emails receivers, which is a dynamic value depending on how the alert email parameter is configured. So let me go to this definition. It is an array. It looks like this. It has name and address. In this case, if you want to enable the alerts to a certain email address, you need to modify this template. This is just an example. You need to modify to have the right address and the name you desire. And then the provided alerts contain, for example, the availability of the service less than 100%, the CPU usage of the application service plan greater than 90%, and other things that you can easily read in the provided files. Once the deployment completes, we can take a look at the resource group in the Azure portal to see the services that are provisioned. This is the resource group we created previously, and you can see that certain services are already provisioned, but the deployment is still running. You can take a look at the deployments here under settings deployments. You can see that the alerts were already deployed, but it is still deploying probably the PostgreSQL DB. The Bicep templates can also include the containers for the blob service in the storage account, which is something interesting, and database for the PostgreSQL database. So having this resource database with parent database server and a certain name, it already creates a DB in the server, which is convenient, because otherwise you would have to achieve this in some other way, for example, through continuous delivery pipelines. And partially, we're going to actually interact with the DB using the GitHub Workflows, because we are going to run the DB migrations automatically when deploying the system. But this is something we're going to see in another video to not mix too many topics. in this tutorial. Oh, the deployment completed. So now we have all services described by the Bicep template into the resource group. And as I said earlier, you see that I'm following a certain naming convention. I have dev hyphen project name hyphen service excluded for the app service. So you have dev Torino demo .azurewebsites.net by default. This is just a detail because generally you would configure a dedicated CNAME, custom CNAME and SSL certificate to use a different name, not this Azure Websites domain provided by Microsoft. And you see by default this page is displaying a hi Python developers, your app service is up and running, because of course we didn't deploy any source code to this service yet. We just provisioned the service which is needed to run our system. But first, now let's take a look how to run these deployments using GitHub Workflows. So we'll go back to the project here. And I will need to go through to settings, secrets. I need to configure some secrets which are used by the GitHub Workflows to run these deployments. So let's also take a look at the GitHub Workflows using Visual Studio Code. As I explained in the first tutorial, the workspace file provided for the server part includes also the GitHub folder, which contains the definitions of the workflows. We spoke about the Docker image workflow, which is used to generate the Docker image. But in this case, we are going to take a look at the infrastructure and infrastructure environment YAML file. We have two, because in this solution, I'm using nested templates in GitHub Workflows, so they are called reusable workflows, to not repeat myself. In the infrastructure YAML file, I contain the definition for the three jobs: deploy dev environment, deploy test environment, deploy production environment. For input, they have environment name, dev, test, prod. They are configured in such a way that the deployment can run on a manual trigger if I decide to run it, because it has workflow dispatch with empty parameter. But depending on the source branch, it will run the deployment for the dev, test, or production environment. So assuming that I have a dev branch, it will create a development environment from it. It can deploy the test services from a test branch and production services from production branch. And other inputs are configured as secrets. Please bear in mind that there is a bug currently in the reusable workflows from GitHub, so that you cannot have dynamic parameters here as an input. For example, when you use a workflow dispatch, you could define some dynamic input like project name, and then potentially you could configure it dynamically here using this notation, but with inputs instead of secrets. But it doesn't work. There is a bug currently, as I said, in GitHub Reusable Workflows, so you cannot do this. But the secrets work. So in this case, for example, project name could easily be an input, but if there wasn't for this bug, but we are going to configure it as a secret as a workaround. So we can have it dynamically configured without having to modify the workflow definition. Here you can see the secrets that are expected by the deployment. So dev Azure subscription, we are going to use the dev environment for this tutorial, so I'm going to configure these secrets. And also bear in mind that you cannot have dynamic reference here. So if you, for example, fork this repository and you want to run these deployments, you will need to modify this string. It cannot be Neotero Torino, it must be your organization or account name plus project name. But going back to the main interesting topic, the infrastructure env file contains the steps to create an instance of the system. So you can see it is running using Ubuntu. It is using the configure Azure credentials to log in the, for example, Azure CLI. It is creating a resource group if it doesn't exist. This requires the Azure credentials to be configured with a scope on the subscription level and not on the resource group level, because when you configure the credentials for the deployment, which we're going to look into details a bit later, you can decide whether to scope these credentials on the subscription, which is perfect if you use different subscriptions for your non-production and production environments, or you can scope them on the resource group. But meaning that if you scope them on the resource group, you will need to create the resource group in advance before running these deployments. And then it is running the RM deployment using the Bicep template. So you have template infrastructure template Bicep and parameters, the parameters files I showed earlier, the password for the application user for the SQL database, the password for the database administrator user, and resource group name as I showed earlier. Environment name, project name, resource group archive. And then this is also something interesting. It is using a provided file to create the DB user for the application, and using the PostgreSQL CLI to configure to run this SQL file, to run this SQL command, and then removing the file because it contains a password. So it creates a temporary file with the password. The original file is this one, create user SQL. You can see here it contains a placeholder that will get replaced by the real password during the deployment. And it creates a user named Web API, granting select, insert, update, delete on all tables in the public schema, and revoking the create ability for the public schema. This is also handling the situation when the user already exists. It doesn't throw an error, but it just logs that the command is skipped. So let's configure the secrets in the project. There are several ways. You could create so-called GitHub environments and configure the secrets as environments. You could configure the secrets at the organization level. But in this case, I'm going to configure the secrets at the project level and without using environments to keep things a bit simpler. So I will copy this. The Azure subscription must be the ID of your subscription. So here under setting secrets, I will click new repository secret. I give the name tab Azure subscription, and I will copy the subscription ID from the Azure portal here. Okay, add secret. Then I will configure the project name. Let me keep this for later, the Azure credentials. Project name Torino demo. The DB SA password, I will put the one we generated earlier. Could be also different, but let's use this one. Then db app password. This is the second secret I generated. Now only Azure credentials are missing. Now to generate Azure credentials, I will use a command that is documented in the GitHub official documentation. I also have it as a reference in the wiki of the project. So let me show where it is. I also don't recall it always by heart. So under configuring GitHub Actions in your wiki, in this wiki, there is this command to be used. So Azure AD service principal create for role-based access control, name of your service principal name, role contributor, which is required to run the deployment. The scopes, as I said, you could have scopes on the subscription level or the resource group level. In this case, I'm using subscription level. And this parameter, this flag SDK out, which is still required. It is being deprecated, but still referenced in all official documentation. So I'm not sure what with what it should be replaced, honestly, because it's not easy to find this information over the internet. But anyway, it is still working. Once it will be deprecated for good, they will probably provide support for managed identities, because in this case, you don't have support for managed identities in the GitHub Workflow runners running in GitHub. You can use managed identities using custom runners for the GitHub Workflows. Again, I will configure a subscription ID as an environmental variable before running this command. And I will copy this command to copy to generate the credentials. Of course, I will reset these credentials before publishing the video, otherwise you could deploy to my subscription. Yeah, as I said, here it says that the SDK out has been deprecated and will be removed in a future release, but it doesn't give any hint about what one is supposed to use. And as I said, it is still documented today in the official documentation about running RM deployments using GitHub Workflows. So this output, the whole JSON will be configured as secret in the repository. So copy. Dev Azure credentials, I will copy this. Whatever you like. So now that I have all these secrets configured, I am ready to run the infrastructure deployment using GitHub Workflows. As I said earlier, this is configured to use workflow dispatch, so I can run the deployment manually if I wish. Of course, you can configure multiple triggers and run them when you wish. An approach I like personally is to use the release trigger, but I'm going to show in another tutorial when we speak about deploying the web application to the service, to the application service. So I'll go to Actions. You see, I already tested the things before recording this tutorial, of course. I go to the deploy infrastructure. I can click Run Workflow for dev. So now when the workflow runs, it will skip test and production, of course, because I'm running from the dev branch, and I have a condition that the deployment can happen only from a branch with a certain name. If I click into the job, I see this, it runs through the steps that I described earlier. So it does Azure login using the credentials I just configured. It creates the resource group if it doesn't exist, otherwise just logs that the resource group exists. You see I'm using the naming convention I described earlier. So I have dev, Torino demo, which I configured as a secret, resource group, and then running the RM template deployment. If everything goes fine, it will do the same, it will happen the same that I ran previously from my local PC, but in an automated way. So when we speak about development environment, it makes sense to run the deployments also manually, as I said, because you can modify the Bicep templates, you can verify that it works without having to wait for an agent to become available to run the job automatically. So it is better to run the deployments manually when you need to verify that the templates work, rather than pushing attempt one, for example, then waiting for the agent to run the deployment. Maybe the deployment will fail, then push again another attempt to fix the template. It wouldn't be a good approach. So now if I go back to the Azure portal, I should see the deployment here, subscription, actually sorry, in the resource group. Yes, you can see that the deployment name template is running. Once it completes, the output should be like the previous run I ran yesterday. The condition was the same. I created from an empty resource group, or actually a resource group with some services. I then deleted the resource group and created it. So it ran the deployment, then it configured the application user running the SQL script I described earlier. Now that once the deployment succeeds, we'll have some, and it just succeeded, we have all the services which are required to create an instance of the system in Azure. But we will need still to configure a few application settings for which are specific to this solution. But anyway, the overall, the idea of how to achieve deployments using GitHub Workflows and Bicep templates is the same. The last thing I want to show are the application settings configured through a Bicep template. So if I go back to the resource group and take a look at the application service, under configuration, here, settings configuration, I have different things. For example, application monitoring key, which is used by the Python web app to configure the integration with Azure Application Insights. This is something I showed in a previous tutorial. It is configured dynamically by the Bicep templates. It knows that the instrumentation key of the Application Insights service is this one, and it is configuring it in the application settings. We have storage account key, storage account name, which in this case is dev Torino demo storage account. And this SCM do build during deployment is needed to essentially prepare the Python virtual environment upon deployment. This is necessary because you couldn't easily prepare the dependencies which might require C compilation and are specific to a certain operating system offline, and then deploy them to the application service from Microsoft, because the library are very likely to require a new compilation. There are two interesting articles on this subject, which I will link in the description of the video tutorial, which speak about the complications of deploying Python web applications without using Docker to a service like Azure Application Service. These application settings are configured in this place of the Bicep template. That is the last information for this tutorial. Here, under project site configuration. If you are using deployment slots to deploy to Azure Application Service in a slot before swapping, then you would need to have twice this configuration, one for the slot, one for the main app. But in this case, to keep the example simple, we don't have the slot here. So for this tutorial is everything. I spoke about Bicep templates. I showed an example which is provided in the open source project Torino. I explained how to run the deployments manually using the Azure CLI and how to run them using GitHub Workflows. So thank you for listening, and have a nice day.